I want to go through the impacts of waves, or at least some of the impacts of waves. The first thing I want you to be aware of is something that's called a rip current. This is never really a rip tide, although that terminology sometimes gets used, but this has nothing to do with tides, and it is indeed a current. These are strong, narrow currents that flow directly away from the shore. Typically, what's going to happen is when you have a situation where there are large waves that break very close to the shoreline, it's going to throw a lot of water up onto the beach, and then that water will funnel out through kind of depressions in the beach, and that takes all of this large mass of water, puts it into a very small area, which then through gravity is pulled straight back out into the ocean. Let's take a look. If you look at this diagram carefully, you can see that when the waves wash up onto the shore, over here you can see that there's all of this mass of water here that I'm circling with the cursor, and notice the way it comes out like this. When it does that, instead of coming straight out here, and straight out like this, the water's going to all funnel out through this narrow corridor. When it does, all of that mass of water that should be going straight out creates a rip current. As I said, this is most common when the waves are relatively large. There's a lot of water that gets washed up on the shoreline. And then the decline of the beach that goes down into the water, in other words, the gradient of the beach as it goes down into the water, has some abnormalities in it. So in other words, instead of being completely exactly the same as it goes down into the water at the same gradient, what happens is there's some places that are a little lower, some places a little higher, and the water's going to take that path of least resistance, which is through the lower area. That can help create a rip current. Sometimes they're visible, like in this one you can see where the orangish reddish arrow, whatever color you want to call that, is pointing, and you can see that there is indeed a depression in the beach there, and the water is pouring out through that depression, which creates that strong narrow current. If you're ever caught in a rip current, and I've been in them many times, if you go out in the ocean, you're going to be in it from time to time. Usually the way it shows up is there'll be a line of people. They're out about as far as most people are, and you notice yourself being further and further and further pulled out, and you recognize, hey, I'm 20 or 30 or 40 or 50 feet beyond everybody, which probably begins you to think that you're going to be in Japan pretty soon, or there's going to be a shark coming after you or something. It's probably because you're in a rip current. All you do to get out of rip current, because remember they are strong, narrow currents, is swim parallel to the shoreline. If you swim parallel to the shoreline, you're going to swim out of them. Mostly they're 20, 30, 40 feet wide, and that's it. And then you'll get out of it and then take the next wave in, and everything will be fine. When you swim against it, that's when you find yourself in trouble, because of course swimming is exercise, and you're going to begin to breathe hard. You're not going to win against the ocean, of course, and you may very well get a wave that goes over the top of you, which then at that point, causes you to inhale water, and now you find yourself in trouble. So just swim parallel to the shoreline and everything will be okay.